Hi class, Mrs. Calvi here. Quick review on finding the LCM and the GCF with word problems. So we have this problem here. Juice comes in packs of 6 and granola bars come in packs of 8. There are 24 players. What is the least number of packs needed so that each player has a drink and granola bar and there are none left over? Okay, so we did this in class, just a quick review again. So we know that juice comes in packs of 6 and granola bars come in packs of 8. We know there are 24 players. So we want to know how many packs of each we have to purchase without having any left over. So we're going to find the LCM of 6 and the LCM of 8. So 6 and 8. Now, what we're going to do is we're going to stop when we get to 24 for each, right? So, actually, okay. So counting by sixes, 6, 12, 18, 24. I know I'm stopping at 24 because there are 24 players and I don't want to have any juice left over. So I'm stopping at 24. So counting by eights, 8, 16, 24. So I'm stopping at 24, like I said, because there are 24 players and we do not want to have any left over. So how many packs of juice do I need to buy? 1, 2, 3, 4 packs of juice. And 1, 2, 3 packs of granola bars. All right, so here you would be finding the LCM in order to see how many packs of each. All right, so let's move on to a word problem that gives an example of finding the greatest common factor. Okay, so here it says there are 12 boys and 18 girls in Mrs. Ruiz's science class. The students must form lab groups. Each group must have the same number of boys and has the same number of girls. What is the greatest number of groups Ms. Ruiz can make if every student must be in a group? Okay, so how do we determine that we are finding the greatest common factor and not the least common multiple? Now, typically, you are going to have where it says, in this case, as it does here, it says, what is the greatest number? That's usually your clue, all right? So typically it would say, what is the greatest number? And that's how you know you are finding the greatest common factor and not the least common multiple. So we are going to find the greatest common factor of 12 and the greatest common factor of 18, and we're going to use the factor tree as we did in class. So 12, 2 and 6, can't go further with 2. 6 can be broken out between 2 and 3. Don't forget, we keep going until we come down to prime numbers. So the prime factorization of 12, because remember, when we do the factor tree, we are actually finding the prime factorization of the number. It is 2 times 2 times 3. All right, so now let's do this for the number 18. Now I can use 6 and 3, I can use 2 and 9. Remember, it does not matter what numbers I use as long as the product would be 18. I'm going to use 2 and 9. I'm done with 2 because it's prime, I can't go any further. 3 times 3, 3's are prime, so I can't go any further. So my prime factorization of 18 is 2 times 3 times 3. Now I have to line them up. So I'm just going to bring these over here, being that I'm running out of space. 2 times 3 times 3. Now remember, we have to circle what they have in common. So they both have a 2 in common. I can circle it. They both have a 3 in common. I can circle it. That's all I can circle because that's all they have in common. Now, if you remember, I'm only taking 1 from each circle. So I'm only taking one of the number 2's and one of the number 3's, multiplying them together. So my greatest common factor here is 6. So in this word problem, what is the greatest number of groups Ms. Ruiz can make if every student must be in a group? The greatest number of groups she has is 6. All right. Hopefully that was helpful, and I will talk to you soon.